Alright, in this video we're going to talk about completing the square. It's a technique that kind of builds upon a formula that we saw when we did factoring called the perfect square trinomial formula. Okay, so this is something you've seen before. It's called the perfect square trinomial. And the formula for this is a squared plus 2ab plus b squared equals a plus b quantity squared. And so we've seen a bunch of examples way back when we did factoring where we had a trinomial that was able to be put in this form, and then we factored it into a sum squared, or a difference. You could use a minus instead of a plus in a couple of these spots. In fact, maybe I'll write it in. If this middle term had a minus on it, then this middle term in the parentheses also has a minus. Okay. All right, so I'll give you a quick example. If we were to factor something like x squared plus 10x plus 25, okay, if you needed to factor this, well, it fits the formula because, first of all, you have a square in the first term, you have a square in the second term. So a squared is x squared, b squared is 25, which is 5 squared. And so the a value is the x, the b is the 5. These are the square roots of the two ends. In the middle, you'd need 2 times a times b. Well, if you figure out what 2 times a is, that's 2x, times 5 is 10x. Right? So here you have 2 times a times b is 10x in the middle. Okay? And as long as it fits that structure, then you can use a perfect square to factor it. So you would factor this into just the a and the b, so it's x plus 5 quantity squared. Okay. Another way to think of this, without using the formula, is just to think, my lead coefficient is 1, and so if I need factors of 25 to add up to 10, they're 5 and 5, right? 5 times 5 is 25, 5 plus 5 is 10, so you get x plus 5 times x plus 5, or simply x plus 5 squared. Okay. Now, that's not too bad to factor these. However, let's say we didn't know one of the three terms. In fact, let's say we didn't know the constant term, and we just had an x squared and a 10x. Then the question is, what constant would you have to add in order to make this a perfect square, in order to make it fit the formula? Okay? And so that's what we're going to be really working with. When we talk about completing the square, it's the idea of filling in the final term so that it becomes this perfect square. Okay? So, here's a technique for doing that. Notice in this example, the relationship between the 10 and the 25 is that if you take the 10, you cut it in half, you get 5, and then square the 5, you get the 25. And this 5 is what goes in the parentheses over here. Okay, so it all hinges really off of this 5. The 5 squared is here, the 5 doubled is here, and the 5 itself is here. Okay? Alright, so let's look at another similar example. Let's say we had x squared plus 6x, and we wanted to figure out what we would need to add in order to complete the square, in order to make this a perfect square trinomial. Okay, so again, using the same idea, I know this is going to be a square over here. Has to be, right? Has to be a square. And this 6 is going to be double the number I need to square. So what I do is I cut this number in half. So divide by 2, I get 3. Right, just like the 10 divided by 2 gives me 5. And then that's the number you square to get the number on the end. So I'm going to square this, I'm going to use the little exponent symbol there, the caret symbol. So I raise that to the second power, and that gives me a 9. So 9 is the number that I need in order to complete the square. Then I know that this factors, this whole quantity factors into x plus 3 quantity squared. It's this number again taken over. Okay? So you get x plus 3 times x plus 3. Alright, so some of these are fairly simple. It's just this idea of dividing the coefficient of x by 2 and then squaring that answer. Okay? So if we just remember that pattern, we can complete a square. So let's try another example. X squared plus, let's say, 14x plus blank. And then the factored form, in fact, I'll put the factored form underneath here. I'll slide this over. Let's put it underneath. Okay, so we're trying to figure out what goes into the parentheses and what goes on this last term. Well, to make this a perfect square, we're going to take that 14, we're going to cut it in half. Okay, divide by 2, you're going to get 7. And then you're going to square the 7, raise it to the second power, and that should give you 49. Okay. Then you're going to take that 7, and that is what goes into the parentheses. I should use the red here, into my factored form. And so we're going to have x plus 7 squared. Okay, so it's all about the 7. Once you find that 7, you're in good shape. So that's half of this middle term. Okay, let's try another one. Take a look at another one. Let's slide this down. Let's try x squared minus 5x plus blank, and then we'll factor it into something squared. Well, this one's a little bit trickier. The reason it's trickier is because I have an odd number in the middle, and so when I cut that in half, 5 divided by 2 is going to give me a fraction, which is okay, I can do that. It's just 5/2. And it's also going to be negative, right? I have a negative in there. So then I square the negative 5/2. Well, I square a negative, it's positive, so I'm good with a positive. When I square the 5, I get 25. When I square the 2, I get a 4. So I get 25/4. And then my factored form is just going to be x minus 5/2. So we can even factor using fractions. It's kind of interesting. Now, if you wanted to use decimals, you could. This would actually, in decimal form, would look like x squared minus 5x. 25/4 is really 6 1/4. So that would be 6.25. And it would factor into x minus, now 5/2 is 2.5 squared. So that would be an alternate form. Okay. I'll try one more example here. This last example is going to involve a fraction. So if I had something like x squared, we'll go plus, let's say 3/5 x. I'm making these a little bit more difficult. So x squared plus 3/5 x, again, you're going to take that middle term, you're going to cut it in half, divide it by 2. Now anytime you divide a fraction by 2, it's like doubling the bottom. So 3/5 cut in half is really 3/10. Okay, so dividing by 2 is like multiplying by a half, so the 2 goes on the bottom. Then you would square that, and that would be what, 9 over 10? Oh, I'm sorry, no, 9 over 100. There it is, 9 over 100. Square the top and square the bottom. And then the factored form, let's switch our color back. The factored form is going to include this 3/10, so it's going to be x plus 3/10 quantity squared. Okay. So we can complete the square now using even numbers, odd numbers down here, sorry, odd numbers, negative numbers, fractions, all of those. But the pattern is the same. So you're always dividing by 2, then squaring. The number down here, this is your b value from the formula, right? So the b value here is always the number, the key number that we're looking for, and that's what goes into the parentheses in the final factored version, okay?